Yes, if you got it finished, I will take it. Now, are there any questions on the homework assignment so far?
I don't remember why I question marked it, but I did.
For last night?
I don't know where that's at.
15. So for 15, it's asking us, well, the instructions say graph the function and its parent function, then describe the transformation. Again, you're not graphing any of these here, so we just want to describe the transformation. So this is a quadratic function. Now the transformation that has been applied is the negative in front of x squared, which tells me that this is a That's it. Because that's the only transformation that has been applied.
Okay.
So for 15, that right there is the answer. Any other questions on 1.2 or 1.1?
Oh, yes, actually.
On 1.2 or 1.1?
1.1. I don't know.
Sure.
If I do that right, set filter notation, is that
For 21?
or all of it?
21, almost.
Oh.
So from 1.1, 21, we're looking at the interval of -5, comma 16. So it shouldn't be a brace, it should be a parenthesis. And we're wanting to rewrite this in set builder notation. So to start set builder notation, we always start with brace x bar. Now, the key is that we're going to have to rewrite this interval as an inequality. So what it's telling us is that we have all the real numbers x from -5 to 16. So we have -5 is less than or equal to x is less than 16 would be the inequality. And that's all we have to put in here. And that there would be the answer. Any other questions? All right. So what we're looking at today is dealing more with transformations, transforming these functions. Now the first one that we're looking at is horizontal and vertical translation. We did these yesterday. We talked about looking at the function and being able to say if it's moved horizontally left or right or vertically up and down. Now what we're doing today is actually applying those transformations to the function. So if we're applying a horizontal translation, we are going to think of it as this here, f of x minus h, where h is the movement to the left or to the right. And vertically, we're going to think of it as f of x plus k. These are going to be the main two for horizontal, left or right, or up and down movements. Because for horizontal, truly we're affecting the inputs, and for vertical, we're affecting the output. What's coming out of the function or going into the function. Now these here are going to make a little more sense when we actually start applying these transformations to the functions. So the first one here, we want to write a function g whose graph is a translation 3 units down of the graph of f. So when we talk about translations up and down, we're thinking of the function, so g of x. Okay, let me actually write this below it. What we're thinking of is g of x, our new function, is equal to our f of x plus k. Because when we talk about a vertical translation up and down, this is the basic function we're thinking of. And this is going to be true for any vertical translations. Now, how far are we moving? 3 units down. So when we go down, so for this here, the value of k is 3, because that's where we're moving. But would it be positive or negative? Negative, because if we go down, it is negative. If we go up, it would be positive. So really, we are minusing 3. Well, this here, because up and down is exactly as we see it. So 3 units down is going to be minus 3. And for this here, we don't have to really think of it as opposite, especially for left and right. Because if it's going to the left, it's minus. We'll plug it in as a minus. Because for our horizontal translation, put this up here. And as you have on your notes above it, y is equal to f of x minus h, yes? So we're plugging that value of h, the left and right movement, in for h. So that minus that throws everything off is already in there, so we don't have to worry about opposite when we're plugging it in. Any other question on this so far? Now, what is f of x? F of x is our function, yes? So we already replaced k with its movement. We're going to replace f of x with our function, because it told us f of x is 2x plus 1. So the f of x here is just saying our original function, what we're working with, is taking its place, which is our 2x plus 1. Any questions so far? We're good with this so far? Now we just need to simplify. So when we look at this here, is there anything in front of these parentheses? Is there a number in front of them besides 1? No. So we can drop those parentheses. So really we're saying that g of x is equal to 2x plus 1 minus 3. Do we have any like terms we can combine? 1 and 3. So 1 minus 3 is? And there's our new function. All right. So we'll look at this here because I think this might be helpful in seeing this. Because our first function was 2x. Nope, not writing, am I? Nope. It's going to want me to click on this. So 2x plus 1, yes? So this here was our original function that we started out with, the problem with, yes? Now the transformation we wanted to apply is we wanted to move this graph 3 units down. So that means every point on this line will go down 3. So at this here, where we have this point 0, negative 1, or 0, 1 is going to go down 3. So 1, 2, 3, it should be at 0, negative 2. Now, if we type the other function in, the one that we just came up with, it was 2x minus. And if we notice, any point we pick, so here is at 1, 3. If we go down 3, it's now at 1, 0. It moved every point 3 units down. And that's all we're doing. We're applying this up and down movement. The same with left or right. Questions on this here? So now, we'll look at the second one. Now, h of x, g of x, all of these here are just a way for us to be able to distinguish between the functions. So I can state more than one function at the same time, and we know which one we're actually talking about. So for this one here, we want to write a function, h of x, whose graph is a translation 2 units to the left of the graph of f. So when we talk about left and right, we're talking about f of x minus h. When we make a horizontal translation, we're using this here. Now again, we're still using the function f of x equals 2x plus 1. You don't have to rewrite that. I'm rewriting it because my screen doesn't include the first problem. Your paper still does. So I'm putting it up there again so we can still see it on the board, since the board is now thrown it above it. But I know on your all's paper you can still see the function right there. So we're still going to be using this function here. Now we're saying it's moving what? 2 units to the left. So our value of h is going to, not this h, but this one here is going to have a value of -2. So it would be -2. Because when we talk about moving left, it is going to be a -2. So we have f of x minus -2. But do we talk about a negative negative? It's a positive. So if you want to, well, really we could switch that over to plus. Now, I would do that as long as you know that we're talking about negative negative, that is making it into a plus. If that you feel like that's going to be confusing later when you look back at it, what we can do is just say h of x equals f of, you can write it right below it, just so that you can distinguish when you look back at it why it became a plus, not that we plugged it in as plus. Any questions on this so far? I have a feeling you just hit the bottom of the page, yes? For your note sheet, or close to it. Now, any questions on this so far before we do the last kind of step and simplify? So, looking at this here, do I have f of x anymore? No, I have what? F of x plus 2, yes? So our normal function f of x is 2x plus 1. I don't have f of x. I have f of x plus 2. I replace the x with what? X plus 2. So on this side of the function, everywhere there's an x, because I replaced this x with x plus 2, yes? So anywhere there's an x over here, I'm going to have to replace it with x plus 2. So this here, we can replace it with the function, so we would have 2 instead of just 2 times x. It's going to be 2 times x plus 2 plus 1. Because whenever we change what's inside that h of x, instead of having, or sorry, f of x, when we replace that x with x plus 2, everywhere a part of that function f of x is now going to have an x plus 2. It's the same, if you remember doing this back in Algebra 1, where it told you to evaluate f of 6, and everywhere there's an x, we replace it with a 6 to figure out what its value is. We're doing the same thing here, but instead of having a nice number to plug in, we're plugging in x plus 2. It does the exact same thing. We ready for the last part? Simplify. So the first thing we can do in simplifying is to distribute the 2. So when we distribute the 2, 2 times x is, 2 times 2 is, plus 1. And that is still our, click on this here, here, h of x. Yes. Mm-hmm. So it would be 2x plus 5. And that's it. Questions on any of this here? Is this as challenging as you thought it was going to be? I mean, there's steps involved. There's a good number of steps, but the overall steps that we're doing from one to the next aren't in themselves challenging. Now, are there any questions on any of this here? Any of this not make sense? Because we do have 2 more that we're going to look at and do this again, so we can at least see it again. Now the first one here, we want to write a function g whose graph is a translation 5 units up of the graph f of x. So we're talking about g of x is equal to f of x plus k. Yes?
Does it matter if we use g of x or h of x?
It does not matter if we use g of x or h of x. Because g of x and h of x are just giving us a way to distinguish the new function from the old one. Because we could use d of x, h of x, z of x, q of x, any letter we want. It's just distinguishing that this is the new one and the other one's the old one. Good question. So this here, so we're moving up and down. So when we talk about vertical translation, up and down, this is the general form we're going to use. And it's going to be helpful to go back to these here so that we remember how it's going to be applied. Now for us, it's moving where? 5 units. So the value of k is 5, and it is positive. Positive 5 because we're going up. And since we still just have f of x, we can just replace it with its function. And the function for this here is questions on this so far? Now we can drop the parentheses because there's nothing in front of it to change the 4x minus 9. And then combine like terms. So the negative 9 plus 5 would give us, and this here would be our new function. Any questions on this here?
So, whenever you do like, the one in front of the 9, you don't use the plus 5.
When we got to here,
Yeah, like you didn't add the 9 and 5, you had to subtract it because the 4x makes you get the better 9.
right, so the minus tells us that the 9 is negative. So we could see it also as, say, 5 minus.
Oh, okay.
Yep, the negative is attached to that 9. So negative 9 plus 5 is really what we're looking at. Yeah. Any other questions? Are you ready for the next one? So the next one, we want to write a function h whose graph is a translation 1 unit to the right of f. So again, when we talk about left and right, we're looking at the function h of x is equal to f of x minus h. Now the value of h is going to be what? Because we're moving 1 unit to the right, so it'll be a positive 1. So we can just write 1. We don't have to put the plus, because if it's not written, we understand that, okay, it's talking about it being positive. It's going to look negative because, again, our general form is x minus h. And again, I'm just rewriting this back down so we can see it again, because for most of y'all, it's just right there. Any questions on what we've got so far? Now, on the last one, we just replaced f of x because at this point in the function, we still had f of x, yes? Do I have f of x anymore? No, I have f of x minus 1, yes? I replaced the x with x minus 1. So in the general function f of x, I'm going to be replacing every x, so this one here with x minus 1, which will tell me that I have 4 times x minus 1 minus 9, because anywhere there's an x, we're replacing it with x minus 1. Questions on this here? Any questions on any of this so far? Now we just need to simplify. So we would distribute the 4. 4 times x is 4x. 4 times negative 1 would be negative 4 minus 9. Questions? So 4x doesn't have any like terms, but the negative 4 and negative 9. Negative 4 minus 9 is? And that's it. Any questions on any of these here? We kind of feeling comfortable with this? Might need one more. Yep. Questions, Zoe, Lily? Okay. I really need to go back and resize these slides because they're a little fuzzy. Let's see here. Highlighter. Unlock. Okay, we can go in. Let's see if I can grab that. Yep. So I think that's supposed to be the right size. But I can fix that and I can get them looking a little bit nicer. They got sized up so it made it blurry. Unlike CSI Miami, making things bigger does not make them clearer. If you've ever watched that show, it's so bad it's funny. It's it's very cliche. It's all criminology type stuff.
Like Cherry's 8 hour. This one,
Yes, f of x equals 3x. And we want to translate it 5 units up. So our new function, it doesn't tell us what the new function is. So we can just pick g of x. Really, you can pick whatever letter you want. G of x equals, so since we're moving it up, it would be our f of x plus k, because if we're moving it up and down, this is the one we use. Because we can start plugging in. Now, for us here, we know that k is going to be 5, and it will be positive because we're going up. So we could have plus 5. Now, what is f of x? And we could put it in parentheses just in case there's some type of sign that we need to change, or if we're multiplying it by something, but are we? No. So we don't necessarily need them for this one here. And that is the final function.
Okay, though, if I do leave the parentheses as my final answer?
Yeah, you can leave them, or if you wanted to just rewrite it and drop them, that's fine. Especially when we're plugging stuff in, it's good to put those there, and then, okay, we don't need them, we can drop them. Because a lot of times, if we're subtracting, that negative needs to be distributed through. Because leaving it with the parentheses in your answer is not wrong. It's just not, we don't need them, but it's not wrong. Any other questions on this one here? F of x equals the absolute value of x minus 3 is a translation 4 units to the right. Well, they didn't give us one, so we can call it g of x is equal to f of x minus h. F of x minus h. Because when we talk moving left and right, we're talking about this one here. Now we need to figure out what our value of h is. Because we're moving where? 4 units to the right, yes? So it's going to be 4. Will the 4 be positive or negative? The actual value of 4 is positive, but now it's going to look negative, yes. That's one of the funny things with the input-output, or when we're affecting left and right, is again, it still ends up being the opposite of what we think, but we don't have to change the sign to make it the opposite of what we think, because we're just plugging that value in. Because when we're looking at it and describing the left-right transformation, then it is the opposite of what we think. But when we plug in its h value, it's just 4 if it's to the right. If it was to the left, then we would plug it in as negative 4. Because then that negative and negative would make it. Okay. Are you ready for the next step? So again, just like the ones before, we don't have f of x anymore. We have f of x minus 4. Let's focus up here. Thank you. So now we're going to replace every x in this function, so this one here, because it's the only one, with x minus 4. So we can plug in our x minus 4 minus 3. Now, since there's nothing in front of those parentheses to multiply through, we can really just drop them. It's giving us this here. Any questions on any of this here? We kind of like this left, right, up, down. We're just using those kind of main features, the f of x plus k or the f of x minus h. Now the next one that we're going to look at is reflections. Reflection across the x or reflection across the y. And again, just like with our horizontal translations and vertical translations, we'll have a similar equation. Because with a reflection across the x, we're looking at negative f of x. Y equals negative f of x. And that's the equation we'll be using to apply this. Or when it's a reflection across the y, we're looking at y equals f of negative x. And we'll be using those exactly like we did for the up, down, left, right movements. Oh, it's hard to see this green, isn't it? Yep. It's done. I mean, if it's not going to be useful for y'all to see, there's no point in having it around. Yep, you're good. So all I wrote was the same thing that we had right there. Yep. So just those two is what we're using.
Oh. Okay.
Yep. So when we look at this first one here, we want to write a function g whose graph is a reflection across the x-axis of f. So a reflection across the x-axis, so g of x, or our y, across the x-axis is our y equals negative f of x. Or for here, g of x is equal to negative f of x. We're applying that negative to the function to reflect it across the x-axis. Any questions on this so far? So what is f of x? Well, f of x is our absolute value of x plus 3 plus 1, yes? That's still just f of x, so I'm going to replace the function with it. Questions on this so far? So do we have anything in front of the parentheses? We have the negative, yes? So we have to apply that negative to the entire function. So the first thing we'll multiply the negative by is the absolute value bars. That negative will not go inside the absolute value bars. So we'll have g of x equals negative absolute value of x plus 3. Then our negative times positive 1 would give us negative 1. Questions on this so far? We ready for the next step? Yes? That's it. Yep. Questions on this here? We ready for the next one? Yes? Because this time, instead of reflecting it across the x-axis, we're reflecting it across the y-axis of the function x plus 3 plus 1. So this time, h of x is equal to, so for the y-axis, we're talking about f of negative x. For y-axis, what we're applying to this function is f of negative x, and that's how we're going to reflect it across the y-axis. Any questions on how we got this started? So really, we're just applying whatever that transformation is. So by definition, across the y-axis is f of negative x. Well, just like when we did left or right, we don't have f of x anymore. We have f of negative x. We replaced x with negative x, yes? So that means over here, everywhere there's an x, I'm going to replace it with negative x. So we'll have absolute value of negative x plus 3 plus 1. Now, if there had been something in front of the x, like 2x, then it would be 2 parentheses negative x close parentheses. Well, there's nothing in front of those parentheses because it wasn't 2x, it's just x. So we have negative x plus 3 plus 1. And that's it.
Why can't we subtract the ones from the 3?
Or combine those two.
Yeah, like why wouldn't we combine
The absolute value bar. Because unlike parentheses, we can't drop them because whatever comes out of that will always be positive. So it's a little bit different than parentheses. Questions on any of this here? So we'll stop here because that's